Let's start off by asking ourselves a question. What makes a website accessible? For a website to be accessible, the site's contents and its functionality should be operable by anyone. This means that a site should offer an inclusive experience to all individuals, regardless of their abilities. To aid us in achieving a universal experience for all users, there is the Web Content Accessibility Guidelines, or WCAG. These guidelines are developed by the World Wide Web Consortium, or W3C, and provide a set of technical requirements for making web content accessible for users of every ability, including people with disabilities who rely on assistive technology. WCAG's accessibility standards are based on 4 core principles. The first principle is perceivable. Web content is presented to users in ways they can perceive. Some examples of this include providing text alternatives for any non-text content. So this could involve including alt text on images or adding text transcripts and or captions on any audio-only content. The next principle is operable. UI components and navigation of content are operable. This means making all functionality available from a keyboard. All functionality that is available by mouse should also be available via keyboard. The next principle is understandable. Information and the operation of the user interface must be understandable. Basically, make web pages appear and operate in predictable ways. Buttons should perform an action, links should navigate you to a different location, the inputs and form controls that users are used to interacting with operate the way that they're intended to. And lastly is robust. Content must be robust enough that it can be interpreted and consumed by a wide variety of users and assistive technology. If you take the first letter of each word, P for perceivable, O for operable, U for understandable, and R for robust, it forms the acronym POUR, and this can be used as a mnemonic to help in memorizing these principles. Each guideline has a set of success criteria that is organized into 3 different levels of conformance. The first is A, which is the basic level of conformance. The second is AA, which is the minimum level of conformance. And the third is AAA, which is advanced level of conformance, kind of the cherry on top. Each level builds upon the requirements of the previous one, and websites are encouraged to strive for at least AA conformance to provide a higher level of accessibility to a broader range of users. Admittedly, the official documentation for the WCAG specifications can be a bit, shall we say, overwhelming. Thankfully, the WebAIM Group, which is another significant accessibility resource, has distilled down the WCAG specs into an easier-to-manage checklist. And as you can see through this checklist, you can filter things through by the level of conformance, so A, AAA, and AA, and then the WCAG version. So it's just a little bit easier to parse and grok through. So let's say you've heard all this information and you're still not convinced that you need to make your site accessible. Well, let's take a look at some statistics and see if that helps convince you a little bit more. According to the CDC, 1 in 4 adults in the US has some form of disability. Although not all disabilities impact internet use, it's important that businesses think seriously about accessibility, as not doing so could exclude a significant portion of their current and potential customer base. There are also different categories of disabilities, like visual, which includes things like color blindness and low vision, auditory, which includes things like hard of hearing and deafness, motor disability, and cognitive disabilities. In addition to permanent disabilities like deaf or blindness, there are other disability personas to consider. For example, temporary disabilities like a person with an arm injury that prevents them from using a keyboard and mouse the way they normally would, or another situational impediment. Suffice it to say that building accessible experiences impacts more users than you might typically think. Lastly, we'll take a look at some legal implications. Increased awareness of accessibility has led to the introduction of legislation around this topic. The first thing we'll take a look at is the Domino's Pizza lawsuit, which involved a blind man who sued the pizza company because he was unable to order food due to the lack of access to the visually impaired. The suit was one of more than 2,000 lawsuits filed over web accessibility in that year alone. On September 28, 2022, the Websites and Software Applications Accessibility Act was introduced to the U.S. Senate and is legislation that is intended to break down the barriers that people face when accessing websites and applications. As you can see, accessibility is a very relevant and important topic, and creating websites and applications that are operable by people of all abilities is something that we should all strive for. A11Y, assistive technology, ARIA, ARIA, accessibility tree. Huh? Yeah, accessibility is a broad and massive topic that covers a wide vocabulary range. So in this lesson, we're going to get familiar with some common terms and acronyms. The first term we'll look at is A11Y or A11Y, depending on how you want to pronounce it. And we'll take a look at the A11Y project's homepage, as I feel like their landing page does a really good job of kind of depicting what this term means. But all A11Y is a shorthand for the actual word accessibility, as there are 11 letters in between the first letter of the word A and the last letter of the word Y. So A11Y. Pretty straightforward, right? The next term we'll look at is assistive technology. And this refers to any device, equipment, software, or service that's used to enhance or maintain the functional capabilities of people with disabilities. And assistive technology can encompass things like screen readers, which we'll take a look at in more depth in the next lesson. There's things like braille displays, and then there's also things like closed captioning, just to name a few. And closed captioning, for example, let's say you're watching a YouTube video. Most videos you watch online allow you to view captions on a video. And so it's just a nice, a visual thing for maybe people who are hard of hearing to kind of be able to intake content in a different format. And in fact, I actually use closed captioning sometimes as an alternative way to kind of receive information in addition to just hearing it audibly. So, both for people with and without disabilities. But yeah, so that's kind of encompasses assistive technology. The next term we'll look at is a big one, and it's ARIA, and it stands for Accessible Rich Internet Applications. This is an acronym that you're going to see used a lot throughout accessibility documentation, as well as throughout this course. And we're going to go through a high-level definition right now, but don't fret. Later on in the course, we have a lesson dedicated solely to ARIA, so we'll take a deeper dive there. And ARIA consists of roles and attributes that allow you to apply additional semantics to elements. ARIA accomplishes this by allowing you to alter the accessibility tree while keeping the page's presentation and behavior intact. And by default, ARIA primarily affects how content is perceived by assistive technology without changing its appearance or functionality. So for example, ARIA will not make an element focusable or apply the appropriate keyboard listeners. So this is an important note here that although ARIA provides a mechanism for applying additional semantics, as developers, it is still our responsibility to ensure that the element with the assigned role functions and operates as it should and delivers on its intended purpose. And ARIA has a couple capabilities that we'll go through. One of those capabilities is that it allows you to implement additional UI patterns. And this is one of ARIA's most beneficial features, as it allows you to implement, UI patterns that are not available through non-native HTML elements. So take, for example, the common tabs and accordion components that you see throughout the web. These are commonly found, but there is no HTML equivalent. So ARIA gives us the capability to implement those patterns in a way that is both accessible and functional. Another capability is that it allows you to apply and modify semantics. So ARIA can apply semantics to an element that has no pre-existing native semantics, or modify the semantics of elements that already have predefined semantics. And doing so provides additional context and descriptive information to an element. So let's take a generic element like a div and apply a role of tab list to it. This would then make that div identify as an element that serves as a container for a set of tabs. And this exact example we'll actually see later on in the interactive section of the course when we implement our own custom tabs component. Another capability is that it allows you to add additional descriptions and labels. So ARIA can add extra descriptions and label text that will only be exposed to assistive devices. So take, for example, using the ARIA described by attribute to establish a semantic relationship and provide more context about the widget it describes. And last but not least, ARIA allows you to do real-time content notifications. So using the ARIA live attribute, ARIA can make parts of the page live. And live updates involve informing assistive technology about changes in real time. So think email notifications, Slack notifications, things like that, where it's kind of important to let the assistive technology device know in the moment that something is occurring. So a common term that you'll see along with ARIA is that no ARIA is better than bad ARIA. And that just emphasizes the importance that using ARIA correctly is imperative. Because incorrect use of ARIA can actually create more accessibility barriers on a website than not using ARIA at all. So, and to help ensure proper implementation of this, The ARIA Authoring Practices Guide, or APG, offers valuable principles for developers looking to improve the accessibility of their websites. And it includes common patterns for things like the tabs and accordions components I mentioned earlier, menus, things like that nature. The next term we'll look at is WCAG, which stands for Web Accessibility Initiative, Accessible Rich Internet Applications. That is a mouthful, but WCAG offers a framework for incorporating attributes that identify user interactions, their present status, and their interrelationships. And without WCAG, certain websites' functionality would not be made available to users with disabilities. And WCAG aids in addressing these gaps by providing a way for functionality to be supplied to assistive technology. So the terms WCAG and ARIA are often used interchangeably, but their definitions are a bit nuanced. And to help reduce confusion, think of WCAG as the framework for the guidelines, while ARIA is the actual attributes and roles that one can use to implement the outline framework. So, or put another way, WCAG is like a superset of ARIA and includes all the features of ARIA while incorporating additional guidelines for making web content more accessible. So to emphasize kind of the nuance between WCAG and ARIA, I'm going to open up the WCAG overview page here, other kind of documentation site. And if you look, there's a lot of technical specs and different resources and things that it points you to, because it's outlining this framework of how to implement WCAG. And so, and it references ARIA within it. So this is kind of showcasing kind of how WCAG is the general framework, and then ARIA are the kind of tools that you can use to implement the framework. The last term we'll look at is accessibility tree. And this is the modified DOM tree that the browser presents to the assistive device minus the extra visual fluff. You can think of this as a read-only API that describes the page's structure. It's similar to the HTML DOM tree, but typically has less information and fewer nodes since it doesn't need all the visual presentation. ARIA enables you to define attributes on elements that alter how that element is conveyed within the accessibility tree. And this screenshot right here is actually taken from the APG homepage and shows kind of what a accessibility tree might look like. And we'll actually dive in here. And if we go to the APG homepage itself and inspect it live, we see that it's very similar to the HTML DOM tree, but has fewer nodes, like I mentioned in the definition. And so you can see things like there's a banner at the top, which includes things like links. There's navigation, which has different list items. There's the main page, has things like the heading, paragraph, links, images. It just kind of shows the main roles that compose, each section. And so this is kind of how the assistive technology devices will take the information and then convey it to the user. So yeah, this is just kind of a view of what the accessibility tree looks like. There are a myriad of other accessibility related terms. However, the ones we've covered in this lesson will equip you with the terminology used throughout this course. By defining these terms and concepts, you will have a better understanding of familiar words and acronyms used throughout accessibility documentation, allowing you to gain a deeper perspective as you continue on your accessibility knowledge journey. Screen readers are one of the numerous assistive technologies available to users. In this lesson, you will learn what screen readers are, what options are available based on your operating system, and some common features and navigation techniques. A screen reader is an assistive technology designed to make digital content accessible to people with visual impairments. Screen readers convey information by converting text into synthesized speech, which can be heard through a computer's speakers or headphones. There are several screen reader options available, but they all generally work in the same manner. When a user navigates to a web page or opens a document, the screen reader reads out the content of the page in the order they are presented in the HTML. This allows the user to listen to the text and interact with the content using a series of navigation techniques. Since most users of a screen reader are unable to navigate using a mouse, keyboard commands are commonly used instead. These commands include things like opening and closing programs, reading documents, and navigating web pages. Windows, Mac, and Linux all have native screen readers that are designed to work specifically with their respective operating systems. In the next couple of slides, we'll take a look at the available options, all of which are free to download and install. By default, Macs have a built-in screen reader called VoiceOver. As a result, no separate installation is required, and we'll look at how to perform basic commands in VoiceOver later in the lesson. On Windows, there is NVDA, which stands for Non-Visual Desktop Access. This is a free and open source screen reader that supports a wide range of applications and can be customized to meet individual needs. To install NVDA, navigate to the download page and scroll down until you see the download button. From here, you can follow the instructions to complete the installation process. Orca is a free and open source screen reader developed for Linux that provides access to the computer via user customizable combinations of speech and braille. For more information on Orca, you can check out the project's wiki and public GitLab repository links that are provided in the lesson manuscript. Now that we've covered the different screen readers for the respective operating systems, it's time to go over some basic commands to familiarize ourselves with this assistive technology. In the lesson manuscript, I provided a table of commands that we will be going through. Since I personally own a Mac, I'll show you how to use VoiceOver as an example. But don't worry if you're not using the same tool as me, as you can always check the instructions for your operating system screen reader and follow along that way. Alright, I'm in the Chrome browser and on the ARIA Authoring Practices Guide website. You will see me reference this site a lot throughout the course, and what better page to test than one that is intended for providing accessible component patterns. The first command I want to show is how to toggle VoiceOver on and off. And the shortcut for this is Command F5.
VoiceOver on Chrome. Patterns vertical line APG vertical line way vertical line W3C.
To toggle it back off, we'll press Command F5 again.
Patterns VoiceOver off.
But of course, we want to actually test the screen reader, so let's toggle it back on.
VoiceOver on Chrome. Patterns vertical line APG vertical line way vertical line W3C. Google entering patterns.
To navigate between focusable items, you'll just press the tab key and VoiceOver will read out the focusable items in order.
APG
to read the previously focusable item, press Shift tab.
APG Home. Link. W3C Web Accessibility Initiative. Banner.
VoiceOver can get a little chatty, so if you ever want to pause the voice at any time, press the Control key. Next, I want to show how to navigate by heading. And the shortcut for this is Control Option Command H.
Heading Level 1. Patterns. You are current. Heading Level 2. Read this first. You are accordion. Sections with show/hide functionality. Link heading Level 2.
To read the contents within the section, you can press Control Option A. And this will read out the content within the card.
Interactive headings that each contain
so for the accordion card, it's going to read the description about the accordion.
Link heading Level 2. Alert.
Then it'll navigate to the alert pattern card and then read the content within the alert card. Next, I want to show how to open up the VoiceOver rotor window. The shortcut for this is Control Option U.
Links menu. Headings menu.
And I'll navigate through the different options that are available.
Landmarks menu. Window spots menu.
I want to go to the tabs link, so I'm going to spell tabs.
Link.
And then press enter.
Link. Heading left.
And that'll take me directly to the tabs card.
You are currently on
to navigate to the page, I'll click enter, and now I'm on the tabs pattern page.
Shortcut Option +0 button.
If I wanted to navigate by image on a page, I would press Control Option Command G.
W3C Web Accessibility Initiative.
There's only one image on this page, so we aren't going to get many options to iterate through, but if there are multiple images, VoiceOver would announce each one in the order that it's presented in the DOM. And that's a brief overview of how to use VoiceOver on a web page. In the subsequent lessons, we will see how to use VoiceOver to conduct accessibility audits on websites and individual components.
Thanks for watching. If you want to keep learning, click the link in the description below.
Throughout this course, we will cover a variety of material. You'll learn the ethos behind why accessibility is important, what the techniques are to create accessible elements, and how to apply those principles during development. We'll start off by laying down a solid foundation that you can build upon. Within this foundation section, we will cover topics including semantic HTML, ARIA, assistive technologies, and how to perform an accessibility audit, just to name a few. The latter half of this course will take the concepts taught in the foundational section and provide hands-on experience building out sample components. As an added bonus, we'll even cover how you can leverage a headless component library to provide an alternative implementation solution. By the end of this course, you will have built a lens for accessibility and have a solid foundation in the fundamentals, along with how to identify, audit, and address accessibility issues. I'm extremely excited to take you on this journey. Let's dive in.